Yes, Ahnaf. Out of all these, which one do you think is the right answer?
B.
Correct. Tape measure with the micrometer screw gauge. Correct. Next question says a man stands next to a railway track. Train is traveling with 40 meter per second. Takes time is 2 seconds. This is the speed. Yeah, what will be the distance?
Hold on.
Yes,
80.
Ahnaf. Which one?
80. D.
Correct. D. See, velocity is distance by time. So distance will simply be velocity multiplied to time. That is 40 into 2, which is 80. Okay, this says that a speed time graph is used to describe the motion of an object. Which quantities are calculated from the gradient of the graph and from the area under the graph? Okay, one from the gradient, one from the area. Yes, Anna.
A.
Gradient, acceleration, and distance traveled. Correct, right. See, I hope you understand. Gradient means what is meant by gradient?
The slope.
Slope, right. So from the slope, you can get the area from a VT graph. And yes, when you want to calculate, if you calculate the area, you will get distance because distance is getting multiplied V into T. Very good. Yes, on the moon, all objects fall with the same acceleration. Which statement explains this? On the moon, all objects have the same weight. The moon has a smaller gravitational field strength than Earth. The weight of an object is directly proportional to the mass. And this says that, last one says that the weight of an object is inversely proportional to the mass.
It's C.
Weight of an weight of an object is directly proportional to its mass. See, acceleration due to gravity is independent of the mass. So all objects are falling with the same acceleration. It's not directly proportional. It's independent of the mass. So this won't be there. So it should be option A. All objects have the same weight. See, when we are talking about the on moon, weight of an object, see, whenever we are calculating, this depends upon the g, and the value of acceleration due to gravity is different, right? So it should be B option, Ahnaf. This shouldn't be, see, C and D are completely incorrect. Remember, acceleration due to gravity is always independent of the mass. So when you're calculating weight, that is mg, this is independent of the mass. Okay. So it should be option B. The moon has a smaller gravitational field strength than the Earth. Okay.
On the marking scheme, it says C.
Marking scheme, it is given C.
Yeah,
And the marking scheme.
I am. Hold on. It it makes sense, no? If the weight increases, the mass also increases. I
Yeah,
mean,
that is right. But when this is correct, see, what you're saying is right, that if the mass increases, the weight increases. But the issue here is that when we are talking and changing the planets, like moon,
there's no comparison of planets, though. That's the thing.
okay, so on the moon, all objects fall with the same acceleration because the weight of an object is directly proportional to the mass. Okay, yeah, maybe since there isn't any comparison, because acceleration due to gravity on the moon is 1.6 meter per second. when you're calculating the acceleration due to gravity is 1.6 meter per second. So this is constant. So yeah, maybe if there isn't a mention with the earth, so this will then C can be the right answer. If earth was there, then the acceleration due to gravity, this statement comes. So yeah, weight will be directly proportional to mass then, because G is itself a constant here. It is 1.6. Okay then, fair enough. Uh, this is done. Fourth. Yeah, fifth one. Yes, Anna. Is there any explanation in the marking scheme? Do one thing, share the
No,
marking
it's
scheme
just I
also.
did. I
You've done?
uh
Okay.
yes.
Is there any explanation also of the MCQs in your marking scheme?
No, it's just the answer.
Okay, okay.
Miss, I got C 1.5 for
Yes,
question
Anna.
5. I got 1.5 for question 5.
C option. A measuring cylinder contains this much volume of liquid. So some more of the liquid is added until the level reaches the 50 mark. Okay. Reading on the balance increases by 30 gram. What is the density of the liquid? So mass is given. The volume is also mentioned. Mass has been increasing by 30. So how have you calculated 1.5?
Uh, I did for the volume, I did 50 minus 30. I got 20. And then for the mass, it's 30 grams. So I did mass over volume, which is 30 over 20. And then I got 1.5.
Yes, correct. See, the weight is increasing, right, by 30 grams. So the mass of the liquid added is 30 gram itself. The liquid that we have added is 30 gram only, then only, this much amount of liquid has been displaced, right? So
Yeah,
yes, and density is equal to mass by volume. So using that, you'll get it. Okay, correct. Sixth question.
it's A, right?
An object on the end of a string moves in a clockwise circular path at constant speed. What is the direction of the resultant in this position? Okay, options must be there, no?
Yeah, it's there now. You can see A, B, C, D.
Hmm. Okay, so you just had to take it from here. Means A only.
Yeah.
Okay, okay. So an object on the end of a string moves in a clockwise path. What is the direction of resultant force on the object when it is positioned as shown? Yeah. Say
A,
a reason.
centripetal force.
Yes, towards the center of the path because of the centripetal force. Correct. Okay, Ahnaf, what is this force, by the way? This one. Hmm?
I don't know what that is.
Okay, you told me towards the center is the centripetal force. What's the formula for the centripetal force?
There's a formula for centripetal force.
Yes, there's a formula.
I don't know it.
mv square by r. Okay, and this outer force is the centrifugal force. This force acts outwards, away from the body, and whichever is acting along the radius and towards the center, that is your centripetal force. Okay. Beam is pivoted at one end. This is the pivot, this is the separation, this is the force acting. All right. Yes, Anna. Try this one. One says vertically downward. So you've understood, no, the question. This is
Yeah.
the pivot. Okay, okay. Tell me.
Uh, it's D.
Yes, right. How did you get it?
Because it says vertically upwards at 20 cm to the right of X. So that would mean it would be 60 centimeters away, right? And it would be upwards. So 60 times 4 would be 240, right? And that's the same as 40 times 6.
That
So
is
it would
240.
cancel out.
Yeah, you will get 240 first, and then you will divide it. So that will be 60 centimeters. Right. So whether it's the left, then that will be divided into 20 centimeters. Okay, correct. You've understood this question, it means. This is the eighth one. Yeah. What is the magnitude of the resultant force of the two vectors? Yeah. Say, this is also a
Hold
very
on.
easy one.
C, 10.
Yes, 10. Because directly 36 plus 64 is 100. Root 100 is 10. Right. Three situations are listed. Okay, this is a complete question. Three situations are listed here. An object has a resultant force acting on it. An object experiences an impulse. An object is deaccelerating. So which situation is the momentum of the object? Okay, momentum changing. Yeah.
Is it C?
And first also, when there's a resultant force acting on it, then there is momentum.
Oh,
It's,
yeah.
it should be D.
Okay.
Because the formula, if you remember, the formula for the momentum is dp over dt. So when there exists a force, then only there will be a change in momentum. If force is itself is zero, then there isn't any change. Momentum is not constant. Okay, 10th question is based upon collision. Mass of one ball, speed of this ball, mass of the second ball, strikes the first, and the second ball moves with this speed. Okay, after the collision. Yeah, this is an easy formula based. Yeah, try this first.
Mm.
Ahnaf, done?
I'm still doing it.
See, and
I
here
don't get it.
the mass is 0.16 kg. So mass into velocity. What's the velocity? 0.50 plus. What's the initial mass of the, see, how do you write? MA, not P, MA VA plus MB VB is equal to, then you write the final MA dash VA dash plus MB dash VB dash. Now these dashes one are after collision one. These are the after collision, and these without this prime, these are the before one. So mass is this, velocity is this. What is the mass of second one? 0.10. What is the velocity of the second one before it strikes? See, it was stationary. So this will be 0. This is equal to, now let's come to the next part. What is the velocity? So what is the mass? It's for this, it is 0.10, right? And it is moving with 0.50 plus, what is the mass of the first ball that was there? Mass is
0.16.
16 and velocity we don't know. So this is the equation. So this term will be 0. This is left, this is left, and this is left. From here you have to calculate the velocity.
Yeah.
Okay. So from here,
Okay.
make the equation simple, like write this as 0.08, remove this, then again 10 into this will become 5 plus 0.16v, like this solve.
Okay. Wait. Okay, and then I got B.
How much you're getting?
0.19.
0.19.
Yeah. Hold on, let me do it again on the
I
calculator.
think it should be 0.3 something, no? When you solve the equation. C option. Check in your marking scheme. What is the option written?
Hold on. So written B.
Okay.
Yeah, 0.19.
Okay, okay. So you've done with this method? Okay. Because I didn't
Yeah.
calculate. That's why I just did it mentally. So that's why I was asking. Okay, great then. So you've got the answer. 11th one. A mass hangs vertically from a spring. Okay. It is, the mass is raised to a point P and then it is released. So, which energy is alternately increase and decrease throughout the oscillations? Yeah, it's a very easy question.
What? Hold on.
Yeah, yeah, read.
Is it A?
Yes, it should be A. Correct. Because gravitational potential energy also acts, kinetic energy also acts, and there is elastic energy also. Elastic energy because of the recoil that is bringing it back. Correct. Okay, this is also a very easy question. So you have this much of kinetic energy, and the car brakes and stops in a distance of 91 meters. Yeah. Tell the force. It is very easy. It will just take a little time for the calculation part, but just try.
Mhm. How would I do that? I don't understand.
See, I'll just tell you in this way. Kinetic energy is there and you have a distance. All right. So
Yeah.
firstly, you have to find out what's the braking force. See, when a car brakes, remember one thing, Anna. When a car brakes, the entire kinetic energy is converted to the thermal energy. Okay, which dissipates into the atmosphere. And some of the energy which is present, this is transferred into the surroundings as sound waves, right? Now you have distance, you have to calculate the force. So see, just see force, kinetic energy and distance. Relate kinetic energy with one of the theorems. So yes, I was saying that one is thermal energy, other part will go to the work done, it will be dissipated. Now look, kinetic energy, according to the work energy theorem, kinetic energy is equal to change in the work done. Sorry, change in kinetic energy is actually equal to the work done. So it means I can equate kinetic energy with work done. What is the formula of work done? Force into displacement. So force should be energy by the displacement. Check, use this. It will come.
Hold on. Oh, I got 6.8.
Did you convert kilojoules?
No.
Then it will be then 6800 then. 1000 will also be multiplied. No, kilojoules.
Yes. Okay, yeah. Hold on, let me write it down first.
So you are getting 6800.
Yeah, I am.
Okay. The diagram shows a deep reservoir formed by a dam. On what does the pressure at X depend? Okay, yeah, tell.
A.
A. H rho G is the formula, height of the water column. Come to the 14th. 14 says a sealed rigid container has fixed volume. Container is filled with air. Okay. So if it is filled with air, it is saying that the container is placed in a freezer cabinet and temperature of the air in the container decreases.
Yeah.
Which row correctly describes what happens to the air container? Sealed rigid container is there, it has fixed volume, the container is filled with air. So basically this is saying that the temperature, once the temperature increases, then what happens, and when the temperature decreases, then what happens? Yeah, this is from your kinetic theory part, kinetic theory of fluids.
What? I don't. Hold on. B.
Yes, right, both will decrease, correct. 15 says that two open containers are filled with water at room temperature. The containers have different shape. Okay, container one is there, other one is there. All right. Then this says that from which container does the water evaporate at a greater rate? Yeah, say answer this.
Container 1 evaporates at a greater rate.
Correct. Container 1.
Yeah.
This says that the diagram shows a liquid in glass thermometer. Then it says, what should a student wishes to check the marking of the upper fixed point of the thermometer. What should she do? Yeah, to check the upper fixed point of the thermometer. So basically, this is related to upper fixed point and lower fixed points.
What does that mean?
Do you know the upper fixed points and lower fixed points for thermometers? Like 0 degree Celsius, 100 degree Celsius.
Yeah.
So what she'll do, she'll put the bulb in a beaker of a boiling pure water because that is the upper limit. See, 0 degree Celsius, she knows, right? But to check the
Yeah.
upper fixed point, that will be 100 degrees Celsius. That is the boiling point of water. So it should be
Okay.
B option. Why not seawater? Because it has salt, so that will affect it. Boiling pure water will be the answer. Okay, 17th. Water in a beaker gains the thermal energy this much. Water at its, okay, specific heat is given, mass is given. Yeah. It is of 2 steps. First, try this.
Miss, I don't know how to do it.
Yes, Anna?
I'm not sure on how to do it.
How to do, okay, I'll tell you. See, first specific latent heat, do you know? It is given
No.
as 226 joules, 2260 joules per gram. Basically, it is the energy or whatever is the energy divided by the mass. That is the latent heat. See, two energies you have. Delta Q is equal to mc delta T. C is the specific heat capacity. This comes in the system whenever there is a change in the temperature. Always remember this. There has to be a change in the temperature. But if the state is changing, like you can see here, water is boiling and it is getting converted to vapor, right? Water to vapor. So then you will use the formula delta Q is equal to ml. So L is the latent heat, specific latent heat. So from here, L is equal to Q by M. So this is the actual formula of it when you're calculating the latent heat. So you have to first find out the amount of energy required to vaporize this much amount, right? You have to first find out the amount of energy. You are taking water, and one thing remember, mass is given already. 250 grams is given. So first step will be you have to find out amount of energy. At least do this step. I'm just giving you a hint. Find the amount of energy to vaporize 50 gram of water. Tell me this. Use this formula. Everything is given here. Now tell me first tell me what is the amount of energy coming. Then we'll calculate the time. Using power is equal to energy by time, we'll calculate the time.
Wait, Q is what again?
Q is the heat energy. Okay. Q is
Okay.
the amount of energy. So L is equal to Q by M. Or straight away, this is the formula. Delta Q is equal to ML. Using that, calculate the amount of energy, heat energy, right? And heat energy, once you have it, you should know the formula that it is energy by time is power. And we already have power. that is 3000 watts. So time will be calculated. That is the second step. But first you calculate the energy, this amount of energy. Then we'll put it into this formula. So time will be simply energy divided by power.
What? I'm not understanding.
Wait. Enough wait. See, delta Q is equal to ml. This you have understood this part.
What is L?
Okay. See, whenever there are two types of heat energies that are involved in your system. One is that whenever there is a change in temperature, there we use the formula delta Q is equal to mc delta T. Now, what is meant by each term? Delta Q is the heat energy. M is the mass. C is a constant which is called as the specific heat constant. Okay. And delta T is the change. Don't write, I'll give you time to write. Okay. Change in
Okay.
temperature. Secondly, Ahnaf, if there is change in the state, okay. Second is change in state. States, you understand states of matter.
Yeah.
Yeah, so there is change in state. Means solid to liquid, liquid to vapor. Like this, there is a change in state. Then the formula is delta Q is equal to M into L. That is called latent heat. Now see, delta Q is what?
So,
Delta Q is the heat, M is the mass. L is this specific heat, specific latent heat, which is given to you in the question.
oh, okay.
Okay. And different for different processes, we have different types of specific heat capacity also. This one, specific heat capacity also, and L also. Like see, if there is a change in temperature, you have a molar specific heat for 1 mole, water specific heat just for water, like this. Similarly, latent heats are also of different type. If the process is vaporization, we use LV. There's a constant given like here, latent heat of vaporization. Suppose the melting occurs. Melting is also called as fusion. So latent heat of fusion is used like this. So different values of latent heat are provided, latent heat of sublimation and everything. The whatever you studied it in your chemistry, the changes in the state of matter. Now the question is saying, the question has given to you power. Okay, it is saying power is given. We are going to give you this latent heat of vaporization also, 2260 joules per gram. And it is saying we are going to give you the mass also, that is 250 gram. But you tell us what should be the time. Now, using this is not a direct question. So see, first using these two concepts, M into L, we can at least get this delta Q. Yes, Anna?
Yeah.
Yeah, delta Q will be M into LB. Now, what is this delta Q? As I have told you, this delta Q is the heat energy. Okay, fine. What are we going to do with this heat energy now? Yeah, we can use these two and we can get heat energy. But see, power is basically energy by time. So whatever value of delta Q you are going to get, you're going to put it here. That will be divided by time will give you power. Now you have power. From here you will get delta Q. So you will be easily able to get time as power by delta Q. That is the question. Clear?
Yeah.
Okay. Write down all these things first.
Okay. Okay, miss, I'm done.
So did you calculate this value?
Uh, I did. The power is 3,000, right?
Yeah. 3000 watt.
And then for the delta Q, it's 2260 times 250, right?
2 times what?
2260 times 250, right?
Yeah.
Okay, when I put it in the thingy, I get I get a really long number times 10
Yeah,
to the
it will be a
power
long
3.
number, right?
It's 5.30973451 times
5 point? 5 point.
yeah, 5 points and then like a bunch of numbers times
Hey, see,
10
Ahnaf,
minus
you
3.
are multiplying 250 with 2260
Yes.
and you are getting 5 point.
No. I'm 3,000 divided by 250 times
Okay. You have
2260.
written it all together. Okay, I understand. You have written this as 3000 divided uh 3000 divided by 250 into 2260. This you saying?
Yes, like that.
Okay. So answer, yeah, you're right. See, the same thing. It's the same thing. When you are dividing it, you will get the answer around 188 seconds.
Are you sure, miss?
Yes, you will get. I've checked it through the calculator. I've not calculated it. Let me
I'm
recheck it. You're getting?
I'm getting 5.3 times 10 to the negative 3.
No, you'll not get such a small number.
But that's what
See,
I'm getting.
see. When you are multiplying 250 into 2260, you will get 56500, right? So when you are having the time to vaporize water, so this will be this divided by 3000. How will you get in any case 5 point something? 3 into 5 is
What?
15.
Hold on, miss.
You have written it opposite. See, you've done it this, no?
Yeah,
Then only you are getting 5. See, Anna. I'll tell you, wait.
I wrote it the wrong way around.
Yeah, that's why you were getting. See.
Then
250
you wrote
into 2260 will be 565,000. Power is equal to energy by time, right?
yeah,
Power is given as 3000. Energy will be calculated. This I told you, no? P is equal to delta Q by T.
yeah.
Yeah. So delta Q means the energy. Energy by time. What is the energy? 565,000 by time. So what will the time be equal to? 565,000 by 3000. Zeros get cancelled. This is equal to 188.
Oh, miss, when you wrote it, you wrote it T equals to P over delta Q. That's why I wrote
Okay,
it.
after this next step.
y- Yeah, after that
Okay.
you wrote
You
the
remember
thing.
this formula. I think by mistake that time I have written it. Remember the formula. Power is always energy per unit time. Rate of change of energy is power. So when you are calculating energy will be power multiplied to time. When you are calculating time, it will be energy divided by power.
Okay.
You follow this. Whatever I've written, I think I just wrote the next step wrong maybe. Look at this formula.
Okay.
Okay.
Yeah.
Okay, Ahnaf. I think we had